Hello everyone. So can you give me a quick note if I'm audible to all of you? Am I audible? Okay, so you people can use your chat box option as such of now. Okay, okay done. I hope you can see my screen also now. Data collection, data cleaning. So in this chapter, in this topic, I am adding one more thing, that is the sampling technique. And you should know which technique we should use before applying the sample size calculation part. So for the sample calculation part, I'm not teaching you the entire things by using the softwares, but I'm going to teach you a few basic things that what we need for the sample size calculation. So in between, we will discuss some exercise also. I have few questions, few tables for you to discuss, and we will take some exercise also in between. Okay, so I think it's a time and I think we can start now with the class. So, okay. The first thing what we are covering up is the data collection and data cleaning and how data collection should be done and how data cleaning should be done and why we need data cleaning as a major step for the analysis part afterwards. Now, the first thing what we have is the data collection thing. So it is nothing but the very important, crucial step in any research process, whatever you are doing, whether it's a retrospective or the prospective, you need to do some data collection before doing any sort of analysis part. Now, what it will do, it will help you to gather the information to answer research questions, test hypotheses, and evaluate the outcomes afterwards. So what you are doing initially, suppose you are planning some kind of retrospective study or some kind of prospective study, you will go to your MRD, you will talk to your patient, you will collect data from the patient, his, her age, her education qualification, what disease he or she is having, what family history he or she is having, and all sort of data collection. Correct? Nowadays, what we use mainly is the data collection form, that is the printed one. So for the masters and for the PhD people, they have started doing something with the data collection manually on the paper. But UG people have allowed to do through data collection by the Google form also. So Google Form they can use, but as such for the PhDs, they want data collection in a proper manner, in some paper printed manner afterwards. Now, what is the importance of data collection? So it will help you with the accuracy and integrity. So this is what, so it will ensure that data, whatever you are collecting is accurate and must be reliable also. So how to find whether data is reliable or not? Suppose here someone is doing some data collection and entering data in the master sheet or the Excel part. Now I notice that some mistake is there in some data. So that part I can cross check with the data what you have collected. That is the accuracy and the integrity of data. The next thing what we have is the informed decision making. So it will help us to make evidence-based decisions in various fields. So as many of you are from the PharmD part, so you might be working with the healthcare sectors, but as the statistical part, we need to deal with multiple sectors afterwards. It might be healthcare, it might be business, it might be social sciences also. Now, to track progress also, suppose your sample is around 120, you are taking data, so we can find out, okay, 120 patients are pending, 30 patients are pending, this much effectiveness we are getting with the data. So while data collection part also, you can recognize, yes, my patients are improving, patients are not improving. Suppose you are doing some kind of RCT, for example, you have found before the trial and after the trial, even though we have not done any analysis yet, but before and after, I was noticing that my patient sugar level was around 480, but after the new drug what we have given, it is coming around 120 only. So we can appreciate that yes, something is improving without the data analysis. The same part we can done with the data collection process also. Now, there are few types of data collection method. The first, the most common part is what? A quantitative data collection. The most commonly used method by the UG people, that is what? A surveys and the questionnaires also. Correct? So in this part, what we are doing, we are collecting data in a pre-designed form, which are available on the online platforms. But remember one thing, as you are very young researchers, you should know basic things about the data collection with the help of some survey. You people might be using some well-established questionnaires also. Suppose you are using some anxiety questionnaire. So this anxiety questionnaire should be available free to use. This should be free to use. So you need to check the copyrights are there or not. So without any copyright, you can take the data, you can collect the data, but during the publication time, they will ask you, did you have the permission to use this questionnaire? So before going for the survey part with the help of some well-defined questionnaire, always check whether this questionnaire is open to use or not. If not, then you mail those people, ask the permission and keep a proof for this part. So suppose you are doing a HRQL study. It is a very hot topic nowadays for the research categories now. So we have something, a lot of HRQL questionnaires. The most commonly used is what SF36. This is the general HRQL scale. But suppose you want to work on the liver. So for liver, we have CLDQ questionnaire. Correct? So SF36 is like completely open to use, but not CLDQ. So for CLDQ, you need to take permission. Permission is required. So permission is like they will send you some agreements that you need to fill and submit afterwards. That is what permission is. Now, second thing what we have is the experiment. So control studies to test hypothesis done by the mainly PG people and the PhD people. Then we have secondary data in which what we are doing, we are going and performing some kind of retrospective study by using some MR documents. That is what a medical records or business sale records. The data we are like already holding with us, but we are searching data back and we are trying to find out some information out of it in that way. Now, the next thing what we are having is again the type of data collection method. The next technique what we are having is the qualitative data collection. Now in this part, what we are doing a proper prospective studies and the follow-up studies. You might have heard about the cross-sectional study. In cross-sectional study, we have two type of papers. Sorry, in the prospective, we have one type of that is cross-sectional and one we have is the longitudinal. So do you know the difference between the cross-sectional and the longitudinal? Anyone? Anyone? Do you know the difference between the cross-sectional prospective study and the longitudinal prospective study? Anyone? Anyone? Or like any guesses? No? Okay. Now what happens in the cross-sectional study is like, suppose you took one patient today for your study. You took the informed consent. Now you were asking some random question to this person and your data collection form is complete now. Done. This is what a cross-sectional study. Done. Let's take one more example. Now suppose you have one more individual, correct? You took his informed consent. You took the questionnaire and that part is also done. Again, you call this person after 1 week, 2 week as per your follow-up time period. And again, you have took the data from the same person. That is what a follow-up study. If you are having some kind of follow-up, is it like 2 days, 1 week, 4 week, 8 week, does that matter? But something is there. That is the follow-up. That will be what your longitudinal study. Correct? If you are winding up in just one shot, that is what your cross-sectional study. Done, everyone? So do we have any doubts or any questions till now? No doubts, no? No, clear. Okay. The next thing what we are having is the focus group. Suppose in this class you want to learn about the research part, like how we can find the sample size, how we can perform the analysis part in here and there. So what we will do, we will talk together, all of us, in this class. Okay, what we can do. Okay, so what techniques we can use to find this sample size. So is it okay to perform the cross-sectional? Is it okay to perform the case control? Can I perform a longitudinal study? So if we all are together discussing a lot of short sort of things, then of course we need to apply a focus groups. The next thing what we are having is the observational study in which there is no intervention. Correct? Suppose you are doing one intervention study in which you have taken the patient, patient got your informed consent, patient is enrolled in your study now. You have taken some blood supplies, you are doing some education intervention, you are doing some kind of intervention with the patient. Now, suppose you have given this patient a PIL, the most commonly used thing among the family people, that is the PIL, that is patient information leaflet, and you were thinking that I might improve my patient disease knowledge, correct? So you are doing some kind of educational intervention, and again, you have taken the data afterwards on baseline and after 2 weeks, correct? Here you are doing some kind of intervention. That is what educational intervention. Okay. So this is not the observational study because education intervention is there. Now suppose one more individual is there. You have taken the informed consent. You have given some sort of questionnaire. Patient has filled the data and that's it. Study over. So in this part, we are not doing any kind of intervention. We are just collecting data from the patient. That's it. Or suppose you went to the MRD, you are taking some patient data about the CBC, LFT, RFT, all data you have collected. So again, this will be what a observational study in which you are just observing the outcome, what is happening to the patient without your involvement, without your intervention. That is what known as observation study. Done, everyone? The next thing what we are having is the data collection exercise. So this exercise is like very useful for the freshers. In this class, we might be having some very fresh people, family one, second, third year people, maybe some new people to the research category. Now, suppose this is nothing but your Google form. Suppose this is your Google form or some kind of data collection form. Now, suppose this is Google 1 and this is Google 2. Google number 1 and Google number 2. Two type of forms we are taking now. Now, in this part, I want you to tell me what is the issue. Suppose you want to find out the name, age, and the gender, correct? And suppose I want to evaluate among this category how many of the patient is having anxiety, correct? I want to check how many of my patients are having anxiety. So in this type of questionnaire, suppose you made this questionnaire, my patient name, my patient age might be up to 18, up to 30, from 31 to 40, for more than 41. You have make this option. So suppose somebody is coming to you telling my age is 22. So what you will do, you will click on B option. Okay. In this category, you are fitting up. Okay. Gender part, okay, you are writing suppose male. Next patient you got, okay, female. Okay, next patient you got, that is female, and again you got female. Okay, done. So what is the issue with this data now? With this type of data collection? Tell me. Anyone? Or like any guesses? What is the issue with this data collection form? No clear information about what? Errors? We did not get the exact age, correct? Number of people missing. That is secondary thing. No issue. That is afterwards. We are taking data. Okay. Number of people missing. Okay. But somebody has answered this question actually, but did not get the exact age. It is correct. The second part is what? The gender part as well. That is male, female, F and female. So in this part, all small, only F we wrote and F capital and all. So as per the data analysis, if you know the SPSS and other softwares, we can know that all this are the single variables. See, female, female, female is a single variable. Male is a separate variable. Correct. So as per us, we are having two variables now. One is male, one is female. But for the data analysis part, we are not having two variables. Total four we are having. How come? Because small male, that is okay. Then all small FEMALE, okay. Then capital F, then capital F, then all small EMALE. This is different kind of data. Now, what is the problem with this age category? You are putting in the categories now, not in the continuous variable, correct? So suppose you found out in your study, okay, so people age range between 19 to 30 are having severe anxiety, are having what? A severe anxiety. Now, if I ask you, you tell me how many of the patient of age 20 is having severe anxiety. That answer nobody can give. Why? Because that data is missing. That is why I'm telling all my people during data collection, try to get data as much as possible, because categorization we can do afterwards also, but in the initial phase only we should have the proper data. So if you are taking data in the categorical part, 0 to 18, then up to 30 or more than 40, even more than 40, then you can't be able to answer few specific question like in this scenario. So if I ask you, tell me how many patients of age 33 is having severe anxiety, nobody can answer. Even I can't answer with my statistics part. So what we can do, always collect data in the continuous format. Categorization we can do, but always try to focus on the proper part. Now suppose you are doing data collection in the Google form, so always try to maintain the uniformity. Correct? So what we will do, for the name part, we don't need as such for data analysis, but for the age we need. So we can write 12, 13, 14, and again 12. Nothing will happen afterwards because 12 will be 12 always. It's not the alphabet, it's a number. So number will be number always. So for the gender part, you write automatically in the option capital M A L E. It's totally up to you. If you prefer, you write M, you write F also, completely fine. If you want, you can write all capital. That is also fine for me. But that uniformity should be maintained. You should not mix up multiple things. Otherwise, we need to change data. And this is why we need data cleaning afterwards. So I hope this part is fine. So this is the trick, this is the formula to start the data collection. Try to maintain the uniformity before the data collection. Correct? So do we have any questions or any doubts now? Anyone? No? Clear? Everything is going fine till now, right? Yes, done. The next thing what we are having is the data cleaning part. So it is what? It is nothing but it is also known as data cleansing or data scrubbing, in which what we are doing, we are trying to identify and correcting the wrong things, or we are improving or we are correcting the spelling mistakes in your data. Suppose you people might be writing something like MALE. You people might write in hurry, that is MALI. You might write MELE in hurry up. No, you will make mistakes afterwards. The same mistake even I have made here. See, FEMAL. It was E, but I made a mistake while teaching you people. Correct? So this is why we need data cleaning. So, okay, I got the mistake. So what I will do, I will put one E. It is correct now. Done. So this is what we do. Now, it involves identifying incomplete, incorrect, inaccurate, or irrelevant part of the data and then replacing, modifying, deleting, and the dirt or the coarse data. Suppose we are doing one data collection in which I am trying to get the HbA1c level, correct? So, what you people will do, you will write for each patient the HbA1c level, what you are getting. Okay, so suppose you are getting around 10%, you got 9.2%, you got 4.6%, you got 5.2%, correct? So HbA1c will be always in the percentage part. So you are reporting percent for every category. Okay, but for the analysis part, we don't need this percent sign. So what we can do, automatically we know the unit of the HbA1c. So in the top column only, while naming the variable, you put percent for your reference, but not for us. As a statistical part, we don't need any unit as such. Correct? So it for us, it is 10, it is 9.2, it is 4.6, it is 5.2. So here what we have done, we have checked the data, we have removed the unnecessary units from the data part. Correct? Okay, question is there any app for data cleaning? No, this is completely manual based. Dr. Nancy. So we cannot do any application use for data cleaning. This is all in our hand, what we are doing. That is why during data collection, you should be very attentive. You should not make any multiple mistakes, because more the mistakes, more the time afterwards for data analysis part. That is why I'm telling you, if you're using a Google form, you make the uniformity there. Doesn't leave any chances of error. Of course, it will come. Error will be there, of course, but if you are having patients, suppose around 120, 150, then it's fine to go. Even I am doing the analysis for the people who are having data of 1000 plus. So of course that error will come up afterwards, but it will be like not that much, because as the statistical part, we know how data coding and data part is coming up. So we automatically converting all the things. So it will not take much of the time also for data cleaning. So once you know the basics of data cleaning, data statistical analysis, then it's very easy for you also. So for data cleaning, I suggest you all can learn Excel properly, because Excel even we also use for data cleaning as well. That's the best use application what you can use. Dr. Nancy. Done. So remember this part, data cleaning. Okay. Now what is the importance of data cleaning now? Again, the accuracy and reliability. So suppose what you are doing, suppose I'm asking you, in your RBC count, suppose, let's deal with the RBC count that is in the continuous variable. You are putting some, suppose 4.2, 4.1, 3.9, and in your centers, you might be having some different kind of unit. Again, that is why we should remove the unit. That part you can mention in the variable part only, like 10 to power 6 or any other unit, whatever you are using in your data part. Okay. Now, what I will do now, this unit will be ensure me, okay, data is going perfectly fine for the analysis part. Now suppose it is coming around 4.2 into 10 to power 3. Then again mistake will happen. Why? It is 4.2 10 to power 3. It is actually minus, not plus. So automatically the number of zeros will be different from the 10 to power minus 6. Correct? So that is what is happening. So we need to maintain data while data cleaning. Try to maintain the same unit for the entire data entry. Correct? So what it will do, it will maintain the accuracy and the data reliability for the analysis part. The next thing what we are having is the consistency. So it will maintain the uniformity across the data set. That is what we are doing. So suppose I am having gender part or any, okay, let's take one more, that is qualification part. Now in the qualification, we might be having UG, we might be having suppose school 10th pass, we might be having 12th pass, we might be having no school, we might be having PG, we might be having PhD categories also. Correct? So what we can do, we'll need to maintain the consistency. So what we will do, some people will write undergraduate, some will write UG, some will write postgraduate without dash, somebody will write post dash graduate. So what is going to happen? We need to maintain the uniformity. So what we can do, put UG as 1, put PG as 2, put PhD as 3, others you can put as 4, 5, 6. Done. So data coding like done already. Then afterwards you go for the data analysis part. Correct. The next thing what we are having is the efficiency. So it will reduce the time and effort required for data analysis part. Now, if you are giving your data that is completely coded, completely clean, it will hardly take 1 hour for me to perform the analysis part. Correct. If your data is not clean, not coded, it will take comparatively more time for me to do the data coding, data cleaning, and the data analysis afterwards. So that is why we request people to do data coding from their own end. So we can give within a few hours. Correct. Then we have improved insights also. So if your data is clean, so it can give me the exact p values afterwards also. Suppose in your data category we are having, suppose let's take around uh, let's take gender. Okay, so I am performing the analysis part. This is what like recently happened with me. Somebody has given me the SPSS sheet for data analysis. So what happened in SPSS also we code the data. That label option will come up for the labeling. So what he has done, he has put undergraduate as 1, PG as 2, and higher degree as 3. Correct, but in his data, he has noticed that some of his friend wrote undergraduate full form, like undergraduate. So what he has done, he has labeled it also as a 1. So, but for SPSS, still we are having 4 different type of variables. So what happened afterward? I got UG, suppose 40 patients. I got undergraduate, 10 patients. I got PG, 20 patients. I got higher degree, 15 patients. For example, even though it is same, UG and undergraduate, both are same, but SPSS gave me 2 different set of data. Correct? So that is what we should do, data cleaning and data coding in a proper manner. So even though if you are using SPSS, even the data analysis software will do the mistake. That is why for my own work, I use Excel for data coding and data cleaning, because Excel will maintain the uniformity throughout the data. Done. So let's take one exercise and I want answers from you. So for the age part, there is nothing wrong. Something is there for the gender and for the qualification part. So you answer me. What is wrong for the gender part now? Answer me. Wait, let me unmute you, sir. Okay, let me change the settings also. Oh, okay, I think you people can unmute yourself now.
May I, may I answer, sir?
Ah, yes, sure, sure, definitely.
So when it comes to gender part, we
Mm-hmm.
have different variables. First, male itself has three variables. First, one is capital M with ALE in small. Second
Okay,
is all the letters in small, and third is just a small m.
correct. So what
Why?
we can do?
So we can maintain a uniformity, like just a capital M we can put in Excel, where you can just put a capital M, and other than that nothing can be kept to to remove the error. And for female you can just keep a capital F, so another letter may not be needed to be entered.
Correct. So what about if I code them as 1 and 2? Is that fine? So what if I code suppose male as 1 and female as 2? Is that fine?
I guess yes, you can do, because there we don't have any other options, so
Of
one
course we
and two can work.
of course it will work. So we can code male and female in this manner and like nothing
Yeah.
wrong we are doing. Completely fine to go.
Yes,
Because
sir.
in the end we need to code afterwards. See, even if you're using the capital F, capital M, you will make mistake in data collection part. And hurry up, you will write small f in between somewhere. So better to code data in the numerical part afterwards. 1212 or 012 012. The same thing we can do for the qualification part here as well. So here we are having UG, we are having PG, we are having PhD now. I think Priya, you can mute yourself. So in this part, what we are having UG, that is completely fine spelling, but we are having PF, not PG. Let me zoom in. So again, it will create a error. Now for the PG part, again we are having small PG. Again a wrong mistake, something is wrong is coming up. For PhD, P dot HD dot one variable, small PhD, second variable, PhD, again a different variable. Correct. So what we can do, we can code UG as one, PG as two. So automatically less mistakes we have like will make this three, this two, and this one. So that's why I prefer to put numbers, not the capital M, small f, because number pattern will not change. Your number will be always a number. Two will be always two. There is not even a small two or capital two. Number will be number. Okay, I think I should mute you all back. Done. So till now, do you have any doubts or any questions for me? Anyone? No? Like any doubts, any question? I'm happy to help. No doubts? Okay. The next thing what we are having is the basics of biostatistics, in which we will learn about some basics of statistics part. We are not going that much deep, but you should know some basics. Now, you can ignore this data, what I'm showing on the screen, but you remember biostatistics is into two different departments. The first is what a descriptive, and the second one is what inferential statistics. Itself, descriptive statistics will be done by a separate department nowadays because it's not the small thing what people are doing. For your projects, you might be reporting, okay, only 40 males are there, okay, 60 females are there. What about the percentage? 40% male, 60% female. It looks like a very simple thing, but it's not. The next department what we are having is the inferential statistics, in which we are trying to find some logic behind the data what you have given to us, in which we need to find some p-value or to apply some test like t-test, chi-square, regression analysis, or we are applying some Pearson correlation, something to find logic behind the data. We use the inferential statistics, but not the descriptive statistics. So this is how this department works. Okay. Now, what is the importance of biostatistics? So, what we do, we actually help you to design the study, how to plan, how to conduct a research studies. I am getting a lot of consultations afterwards that this is my plan, this is the data what I have collected. Then I will try to find out how I can save that person from the ethical committee from the main trouble afterwards. Because you should consult us before the planning of study. So I can tell you like how data should be collected in that way. So if you people are planning a study, please contact me. I can help you with the data collection part as well. So the most common mistake what people do with the case control is like they don't match the age, gender, and the etiology part. Now suppose you are doing one study, that is case and control study, in which you are taking suppose breast cancer patient along with some drug, suppose X. You are taking a breast cancer patient with a drug that is Y. Correct? Now you want to check which drug is much better. So what we should actually do, we should match all the female age, because breast cancer will be primarily in the female part. You are focusing on the female only. So take female gender, completely fine to go. Try to match the age also. So if your one case suppose is 20 year, try to match with 20 year in the control also. Correct. Now suppose you want to check the etiology also. So try to match both the things in both the group, case and control. Now suppose, let's take one more example. Suppose you are doing some kind of study to find some potential predictors now. For example, now suppose you are doing to find the potential predictor for the sickle cell anemia by using the CBC. Okay, so what you are doing, you are making a case and control group. In which part? Case group, there is sickle cell anemia. Other group control, there is no sickle cell anemia. So what you are doing, you are taking all the patients. In the case, try to match gender also. So if you have taken 20-year-old male in case, try to match the same patient with the 20-year-old in the control group as well. So what it will do, it will remove the co-founding factors from the data. So it will give me true data afterwards. So that is the trick for case and control. Done. Now data analysis part will also help you to find some logical reason behind it, like what data is actually telling you. The next thing what we are having is the interpretation. So with the data what we are getting, we can actually give you the interpretation. Okay, in your study we found out that cutoff, suppose we found out suppose at hematocrit level of less than 4.20, suppose mg per dl is the potential predictor for predicting the sickle cell anemia. Correct? We are helping you for the interpretation. Correct? We are also helping you for data presentation also. So what we will do, suppose we got 50 patients with sickle cell, we got 50 patients with control group. Okay, so what we will do, we will give you one good pie graph. Correct? We will give you some good ROC curves also for the cutoff. That is what we will do for with your data. Let's do one exercise. This is, I think, Jamovi. This is Jamovi, yes. Software. From this, we got this data. Now, in the first part, this is what data inference will look like, in which we are trying to find some p-value out of it, correct? So it will tell me about the test what we have applied, that is Mann-Whitney U test. We got p-values also for the two variables what we have checked, correct? Now suppose here we are having group that is 0 and 1. Suppose this is male, suppose this is female, again this is male, this is female. Correct. So what we can tell, okay, among the male, what we are having a mean of 8.34 plus minus 6.37. Correct. In this way, we can give some data to you afterwards. What about the p-value? Nothing. It is coming 0.203. That means significant difference is not there. Correct. This is how data information, like data logic is runs behind. Let's take one more simple example from this is okay. This is a sounds like a chi-square table. This is your p-value, what we are getting. Now suppose nausea, this is your control group. Suppose case, this is your control group. Okay. This is what your number of individuals in each group. Okay. If I am asking you, tell me which group is having more amount of nausea. So what we will answer? Okay. Group number 2, that is ESPB. Out of 20, 10 patients are having nausea. What about the group 1, that is ISB? Out of 27, only 3 patients are having nausea. Is it significant? Yes, it is significant. How come? Because 3 patients are having nausea. Is it significant? Yes, it is significant. How come? Because 3 patients are having nausea. Is it significant? Yes, it is significant. How come? Because 3 patients are having nausea. Is it significant? Yes, it is significant. How come? It is 0.028. That means significant. So if your p value is less than 0.05, it will be significant for sure. Correct? What is p value and how to find it? P value is the main thing in the statistics part. So once you are performing the inferential statistics, automatically you will get some p value out of it. If you're applying a chi-square, you will get one chi value, you will get one p value. That p value will tell you whether this is significant or not. Correct? Let's take one more part, that is the 0.0129, that is the p value, that is the vomiting, yes and no. Okay, so if I ask you in which group people are having more amount of vomiting, of course it is ESPV, correct? But is it significant? No. How come? P value is what? 0.129. So this is how we make logic, we make a decision out of your data, whether this data is coming in a good way or not a good way in that way. So do we have any doubts now or any questions? Anyone? No, clear? Everything is going fine? Please ask, please ask. Vikram, please ask. Okay, what is Jamon app? It's Jamovi Ashwarya. This is for the data analysis part. No, Dr. M. No. Okay, okay, wait. Let me unmute. Yes, you can ask now.
Uh, Siddesh, it was really a good presentation. But my one question, you said that the p value is 0.129, but it's not significant. So could you please elaborate the word what the significant means over here? So it's less than 0.05, or what does this mean?
It is 0.005. It's 0.05. If it is coming less than 0.05, then completely fine to go. You can report something is coming significant. In statistical paragraphs, we write 5% level of significance. That is what 0.05. So if your p-values come less than 0.05, that means that outcome is significant. But you should not rely on the p-value for the clinical part as well. Suppose
Mm,
in your patients, suppose bleeding is the major thing what you look for.
mm, mm,
Probably in the statistical part, we are not getting p-value about the significant part. So getting a p-value significant does not change your clinical practice also. So suppose
mm.
in my data, I told, okay, your data is showing that bleeding is not a significant factor for this disease, but this is the main factor for your diagnosis part, correct?
Okay,
So
got it.
p-value will not change your diagnosis or your clinical practice, but it will show you like where something is going on. Let's take one more example. Suppose I took your exam for this class, whether my people are improving or not after the class in
Mm-hmm,
respect to the statistical part, correct?
mm-hmm.
Suppose I got a significant p, well, that is okay. I got significant improvement in the marks. So significant p value will tell you, yes, something is going on behind these factors. That's why it's coming significant. Now, I took your class. So, but your score significantly improve afterwards. But what is the reason? Did I take your extra classes? Did I beat you to learn? Did I lock in the room to learn proper way? So multiple factors afterwards you need to investigate once you're getting the significant p value. So that is the role of p value. It will give you the green flag where you need to investigate more.
Got it. Why it is happening that we need to investigate. Okay, okay.
Yes,
Yeah, yeah.
correct.
Got it. Thank you. Yeah.
Okay. I think somebody has asked. Only for drug? No. We can do for anything. If you want to check anxiety is there or not, you apply chi-square, you will get some p value out of it. Okay. If p value is more than 0.05, no, not significant. Okay. If the number of patients are 30, then what that 10 by 20 indicates? Maybe 10 patients suffer from nausea. No, I will tell, don't worry. Okay. So suppose what happened with this part? I am dealing with 30 patients, correct? In the end, I found out only 20 patient data I'm having for the nausea, not the other 10 patients. That is why we are having 20 patients. So even though if you are running behind the t-test or the chi-square, it will only evaluate the data that is completely present. So what other mistake you people will do is like you will write NA or write 0. So NA and 0 itself a variable for the analysis part, correct? So if data is not there, you keep that cell complete blank. So during the analysis part, the automatically software will catch those cell which is completely filled, not blank. That is why it is coming 20, 24, 28, 29, 28, 27. Done? I think that is
Sir,
the last.
but
Ah,
in this data, it is like the addition of both is coming to 30. So like in the bracket, it is said yes slash no. So if we coincide the data,
yes, that is correct. Yes, correct, Mohit, correct. That is correct. Yes and no. Yes, correct. Good, Mohit. Good, good. Okay, others, do we have any doubts?
So Siddesh, the 10
Ah,
by 20, what is coming for nausea? That means that for 10 patients there is a nausea and 20 patients there is no nausea.
correct,
Correct? And the same thing and the same principle applies to other three as well for group ISB as well as for ESBP. Correct?
correct.
Yeah. Thank you.
So for
Yeah.
etching, if I tell out of 28, out of 30, okay, two patients are having etching. 28, there is no etching.
No,
That is
it's
what it is showing. Okay.
hmm, got
Okay. Now let me show you one more thing, some data presentation part. Okay. Now the first graph what we have is the scatter plot. This is known as scatter plot. It will tell you the correlation between the two factors. Correct? For the correlation, your data should be either continuous or might be having one data in the ordinal phase. Correct? So in the data analysis part, you will come across scale data, the ordinal data, and the nominal data. Correct. So what is scale data now? All the continuous variable. Your hemoglobin for all the patient, 8, 8.2, 8.4, 9.2, 9.8, all. What about the data which is in ordinal? That means some order is present. So suppose if I take undergraduate, postgraduate, and PhD, so of course some order is coming up. Suppose I am taking assistant professor, I am taking some associate professors, I am taking the HODs, dean. So of course some order is coming up. Correct? This is known as your ordinal data. What about the nominal data? Where nothing is there. There is no order. Suppose let me take gender. So male and female. So male and female itself a separate variable. So like there is no order like before male, after female, nothing is there. That's why it is what a nominal data. Correct? So for the scatter plot, you need
Sir,
two type of data.
one
That
word.
is what, yes.
Indovana, not
Hello.
connected, Choki. तो चालू हो रहा है नवी तो बंद.
Okay, let me unmute yourself. Okay. Okay. Now for the scatter plot, either you need data which is in the continuous variable or you should take data that is in the ordinal category. But at least one should be ordinal. Otherwise, the best preference is what both should be ordinal. In this part, we are taking C3 percentage, we are taking hemoglobin percentage also. So what it will tell us, correlation part, either positive or the negative correlation. So this graph is showing positive. Why? It is going in the upward direction. Correct. It indicate if HB increases, then automatically C3 increases. Correct. This will give me the PSNR and the P value also afterwards. But we're not discussing that much deep about the statistics part. The next thing what we are having is the graphical presentation of data on the VAS score. So VAS is nothing but the pain score, what they use in the operation theater, like 0 to 10, mark your pain scale, all those things. Okay. So what we have noticed that it was 3 by 3, then 2.9, then it is significantly decreasing for the ESPV. What about the ISB part? It is maintaining some kind of uniformity in the data. So this is how data presentation will come up for this part. So that is also a very important part in the analysis. You should know how to perform the analysis and the data presentation afterwards. Okay. The next thing what we are having is the key concepts in the biostatistics part. The first thing what we are having is the type of data. The first thing is what a very simple kind of data, that is the qualitative, in which we are having some category. Suppose I am taking blood type, that is A plus, sorry, A, B, A, B, O. Whether you are like having diabetes or not, yes or no. Whether you have hypertension, yes or no. Automatic one category is coming up, correct? The next thing what we are having is the quantitative data. That is what some numerical is present, some continuous data is there. We are having age, blood pressure, cholesterol level, any number that is coming in the continuous format. Suppose in this class, I'm having around 170 individual. If I ask all age, like 19, 20, 21, 30, 40, some random numbers will come up, right? That is what your continuous variable. So in this class, if I ask, okay, how many males, how many females? Okay, that is what your categorical data. Done. Simple things. Now let's do one exercise. Now this part, the first table is what? Gender. So this is what? Quantitative or qualitative? Answer me. Okay, suppose one is male, two is female. Now answer me. This is what? Correct. What about the other one? Suppose I'm taking the age now. That is mean plus minus ST. This is what? Correct. So remember one more thing, I came across many papers now while doing the correction, people are writing mean plus minus ST and not in this manner. They will write 46.57 plus minus 14.2. So this is not the correct way of writing the standard deviation, plus minus sign. You should write in this manner, above one, not the below one. Correct? It was a simple exercise for you all. Now let's discuss about the descriptive statistics. Now, two things what we usually do, that is the measure of central tendency and the measure of dispersion. Correct. Now in the central tendency, this is what? Nothing. But suppose in this class we are having around 175 individual. Correct. So if I call each and everyone and I ask for the age, okay, some will be 19, some 20, some 21, some 24. Up to this, I'm getting around 175 variables out of it. Correct. After a few minutes only, after a few seconds only, I can't even remember the single age of the one single person. Suppose in this class, if Ramsha told, okay, I am 21-year-old, after I asked an individual, I will forget her name, like her age also, like what was your age in that way. So what I will do, I will try to find a single value that can represent the entire class together. Correct? That is what known as central tendency. If you can describe the whole set of data by using only one number, that is what a central tendency. The most common thing what we use is the mean, then we use mode, then we use median. Correct? But you people should be able to know because people are performing statistics part on their own and they are reporting a lot of issues afterwards. Now, mean is like what? The most commonly reported outcome. So what is mode now? As per the definition, what is mode? Anyone? Okay, let me unmute you all. Allow participant to unmute. Yes, most frequent number. So mode is what? The most frequent number. What about the mean? This is nothing but the average. Okay. What about the median? It will be a number that can equally divide or divide into two equal parts. It's the middle number. Correct? It will divide your data into two equal parts. That is what known as median. Correct? Now let's take one example. The most common problem I'm getting nowadays is like people are doing statistics by their own without knowing the basics first of all. So I got data that is suppose 142.4 plus minus 14.1. Let's take one more part that is 132.4 plus minus 140.24. Correct? I am giving you two options now. You tell me which is correct. You tell me which is correct. Why not second?
First.
Why not second?
So Siddesh, second is not correct because then this is not a median or anything. This is just a number or a prayer. This error,
Error like what?
typographical error.
No.
No.
See, statistical way part will not give me any typographical error. No.
Okay. Yeah.
Suppose in the statistics tables, I'm getting 132.4 plus minus 140.24. So statistics will not give me any wrong data or the like wrong number. So
Mhm.
this data represent what?
So
Ah, yes.
a smaller number is written first. So if we subtract the smaller value, the answer will be negative.
Yes, that is what the SD part. Correct. That is completely fine. But people are reporting such type of data. So this represent actually, if you see this type of data, the first thing should come to mind whether my data is equally or not distributed. Okay. For this data, apply Shipro will test. If it is coming significant, that means data is not equally distributed. So for this part, we should not be reporting mean. We should be reporting median. So how to report median part? You apply interquartile range. So you will get three numbers out of it. That is the 50 percentile, 25 percentile, and 75 percentile. So this is how you should report the such data. Correct? The first one is completely fine to go. The other one is completely wrong to report. So if you report data like that, that means you have used all the wrong tests also. Even though you are having some data that is not equally distributed, even your simple t-test will be wrong. You even cannot use the t-test. You need to use the man-Whitney u-test afterwards. So that is why you should always check whether my data is equally or not equally distributed. Correct? So this was all about the data distribution part. Now the next thing what we should be learning is the dispersion part. Now in the dispersion part, this is those numbers that rotate around the mean values. So take the example of class toppers, correct? So during the exam part, what will happen? Some classmates will be nearby the topper people or people with having some good amount of notes, correct? Those people are like what? A dispersion number. So what is dispersion number? This number will be always surrounding the major values or the mean or the central tendency value. That is what known as measure of dispersion. It contains what? Standard deviation, mean deviation, interquartile range. It contains range also. Please unmute yourself. Correct. Now for the research part, what we are doing is like we are reporting standard deviation but not mean deviation. Can someone tell me why? Anyone? So range is what? Maximum minus minimum. Simple. ST, interquartile we just have discussed. So for the research part, we are reporting 14.2 plus minus 1.2. This is what a standard deviation. But why we are not reporting the mean deviation now? Answer me. Anyone? Average value are not considered. No. Okay. So for the analysis part, we need to focus on two major things. That is what? A magnitude and the direction. These are the two major things, correct? What about the first part? It will tell me the data, how much data is spread from the mean value. What about the direction? This will tell me how much data is going in which direction. Is it positive or in the negative direction? You might have learned about this scale in your 9th and 10th mathematics also. Negative and plus side direction, correct? This is what the direction part from the mean value. The problem with standard deviation is like, sorry, with the mean deviation is like, it has the magnitude but not the direction. Why? During the calculation of the mean deviation, we are automatically changing the negative data to the positive data. So automatically we are losing up the data direction. But with the help of standard deviation, we are having both a magnitude and the direction part. That is what important. And that is why we are reporting ST, not MD for research categories, for the research numbers. Done? This part is done. Everyone, do we have any doubts or any question? Okay, please repeat. The thing is, we have two things, that is mean deviation and the standard deviation. For the mean deviation part, we are having magnitude but not the direction. So what is first of all magnitude? It is like how much data is spread from the mean value. What about the direction? It will tell your number direction. Is it positive or negative? Correct? But the same thing is not there with the standard deviation. Correct? It will report your direction. It will report your magnitude. So what is going wrong with the mean deviation calculation is like, during the calculation of mean deviation, we have to follow some certain rules. One of the rule is like, if your data is negative, so what we can do, change into the positive automatically. Correct? In the standard deviation, what we are actually doing, we are putting the square out of the number. So if data is in negative, suppose we are doing the square, we are getting some number in positive. So we are changing with the logical manner for the standard deviation, but not for the mean deviation part. That is why for the mean deviation, direction is missing, but not for the standard deviation. That is why for the research, we always report mean plus minus SD, not MD. Done, everyone? Now, the next thing, it is very important now, what we are learning now, that is the data distribution. So in our college, in our school, we have two type of teachers. One is very strict, one is like very lenient with all of you. So if your strict teachers tell you are failed, that means you are failed. Correct? But then we have some good teachers also. So okay, I will pass with extra 2 marks. Don't worry. The same thing will happen with the data distribution also. So we have two type of teachers. The first is what kurtosis, a very strict teacher. Then we have squealiness, a very good teacher. Correct? Kurtosis follow a rule of zero. If it is zero, then it's completely fine distribution. So what kurtosis will tell? How much data is spread? How much data is flat? Correct? This is what kurtosis will tell you. Okay. If it is zero, that means data is completely fine to go, like no issue. If your coming data is in positive, like 0.1, 0.5, 1.5 plus in the plus direction, that means you are having what leptokurtic. So this is what a leptokurtic. This data will be what a long and thin. Correct. Then we have one more, that is negative kurtosis. Correct. This will be known as plutocurtic. That is what your data is completely flat, like this part. So if your kurtosis is zero, that means you will get a proper bell-shaped graph like this. Okay. But for the number part, remember that zero is the cutoff. That means data is completely fine to go. If it is in the positive direction, you think of what long and thin. If it is in negative, think of what short and wide. Correct? What about the skewness? It tells if your data is like perfect one or minus one, complete one, not points. 1.0 plus minus 1.0, that's it. That means it is perfectly asymmetry. Skewness will tell you whether your data is in symmetry or not. Correct? If it is plus one, negative one, that means complete asymmetry is present. If it is zero, then completely fine to go. We are also happy to accept your data if it is minus zero point 0.5 to 0 or 0 to plus zero point 0.5. It is also acceptable, but not plus 1 or minus 1. Correct? Remember the cutoffs 0 to zero point 0.5, both the directions, 0 and plus 1, both the directions. Correct? Now you might have heard about the negative squid, positive squid. That is the most commonly discussed things also. Correct? Now this is what we can follow, the perfect bell-shaped graph is there. That means it might be having a zero squidness. That means data is perfectly symmetrical. Correct? Now remember this table, negative and positive. This is what we need to learn in the 9 and 10 classes. Okay. Now if your tail is going like this, just try to follow my cursor. See, and for this part, we are having like this. Correct? Now, the first one is what? Zero. The other one is what? A positive squid. This is what? A negative squid. You just need to follow the tail. Tail is long in which direction? It is in the positive direction. Correct? Try to match with this diagram. It's a trick to remember this part. It is your graph. Correct? This is negative. This is positive. You need to recall the tail size. Tail is long in which direction? So for the positive part, tail is more in the positive side, but for the other part, negative side. Done. Now let's take one more thing. Just a minute, one important call is coming up. Just 2 minutes. Sorry, some important call in between. Okay, the next thing what we are doing is the hypothesis and the null hypothesis part, the most common things in your research part. Now, what is hypothesis? This is your prediction. After this class, everybody will pass the statistical exam. That is my hypothesis. So exam happen, everything happen, people fill in the statistics part, that is my null hypothesis. Completely invert, completely ulta of my hypothesis. Initially, whatever you are thinking, that is your hypothesis. If it is not coming positive, coming totally ulta, that is what your null hypothesis. Now suppose, now suppose I tell you this plant will grow in the presence of sunlight. This is what my hypothesis, this is what I need to prove, correct? But I found out if I giving my plant artificial light or sunlight, there is no difference in the height or the growth of the plant. That is what my null hypothesis, correct? So what is your hypothesis? What you are initially planning? Okay, RBC count less than 10 will predict the anemia, correct? But it is coming out to be 7, not 10. So 7 is what the null hypothesis. Done. Done, everyone? This is the simple definition behind these two terms. So initially what you have predicted, that is your hypothesis. You think of something inverted now, then that is what your null hypothesis. Correct? The next thing what we are learning is the sample techniques. This should be very, very important before going into the sample size calculation part. Now, sample technique is very important. I have noticed people are randomly doing some research without getting any sample size before the research. It is the problem because nowadays even the local journals are becoming strict to get some sample size formula. In your paper, in your thesis, you should be able to create one paragraph of sample size calculation. Report how come you obtained that sample size with the formula. Done, because that sample what you are taking will represent the entire population. Correct? Suppose I am doing one study. Recently, I have given one sample size of 1600 to an individual who was performing something on the NAFLD in the society. So he got around this much sample size, 1600. So this 1600 represent the entire population of the NAFLD. That is why it is very important to find out the sample size and it should not be biased. Correct? Now, what techniques we can choose for sampling technique? The first thing is what convenience, then simple random, then certification and the systematic sampling. Okay. Now let's discuss one by one all the techniques now. The first technique what we are having is the convenience sampling. Okay. What does bias indicate here? Bias, you think like, suppose, uh, Vikram. Okay, Vikram is asking. Okay. Now suppose, Vikram, in your class, we are having you. This is you in your class scoring 90 out of 100. One of your friends, suppose Amit, scored around 70 out of 100. Okay. So, but what I'm doing now, on the basis of your score, I am taking you for the internship. I'm not taking Amit. So what I'm doing, I'm creating a bias here. Okay, Vikram is more intelligent, so more, less power, less investment will be there for Vikram to learn the new techniques. That is what a bias thing is. Okay, let's take one more example. Suppose in this class, out of 175, 50 people are my favorite, complete my just my true friends. Okay, rest I don't like. Okay, so what I will do, I will pass all this 50 individual, rest 130 I will make them fail, complete fail in the exam. Done. This is what bias is. If you are supporting something intentional, then this is bias. Now again back to our sampling part. The first thing is what a convenience sampling. This is what we do with the retrospective study. So if you are doing some retrospective study, they ask you which type of technique you have used. Answer is very simple. That is the convenience sampling. What I got, I took. That's it. Okay. Suppose this is the category of people what we are dealing with, and I'm taking only first row. I will select him like starting first row. I'm selecting for my research. This is what a convenience sampling. Correct? Or suppose I'm choosing a third row, not first or second. This is what my convenience sampling. As per my things I'm working. That is what known as convenience sampling. Let's take other thing that is simple random sampling. Okay, so what I'm doing now, let me remove all these markers. So what I'm doing now, okay, in the first row, I will take randomly two people. In second row, I will take randomly three people. In third row, I am taking randomly four people. One, two, three, four. This is what known as simple random sampling. Correct? The next thing what we are having is the stratification of the sampling. Suppose in this class I am doing a research and I want to do some stratification. So what is stratification? I am creating a subgroup before my study sample only. Correct? Now suppose in this class I'm having around how much? 175 individuals. So I'm asking you all of you, how many of you are age under 20? Okay, under 20 we are having around 20 individuals. Correct? What about uh, wait, let me mute you all. Suppose if I'm asking you how many of you are of age 30 to 50. Okay, 60 we got. So what we are doing, we are getting a sample size of what 80. Correct? But what I have done, I have made two groups out of it. People who age less than 20, people who age between 30 to 50. That is what known as stratification. Done. Let's take one more thing, that is the systematic sampling. Okay, so in this class, suppose now I'm having around 176 individuals. Okay, and I'm thinking, okay, let's plan one prospective study to evaluate the rate of depression, anxiety, stress among this individual by using a dash questionnaire. Okay, this is a available questionnaire for depression, anxiety, and stress. Correct. Now, out of 176, let me perform a study and I will take some systematic sampling. So, this is what, suppose I arrange you all. Suppose this is 1, 2, 3, 4, 5 to all 176 individual. This up and down, just for the reference part. Okay. Now, I am taking a systematic sampling. That means what? I am taking a random number to get my participant. So I'm taking suppose, okay, every second division I will take for the sample size. Okay, I will take number 2 because what I'm following, I am taking always a second number in my data collection form. So second, then I will take 4, then I will take 6, then I will take 8, then 10, 12, 14, 16, 18, 20. So out of some people, I will get some random number out of it. Correct? So in this part, I'm not aware in this line, people, how will come? People might go up and front, but no need to worry. You can start from any number, no issue. Okay. So suppose I don't want to take number 2, I want to start with number 4. Okay. So number 4 is what? My number, patient number 1. Then patient number 6 will be my second individual for my study. So you are selecting patient from some numerical part. So suppose in this class I am taking individual from each fourth individual. So 1, 2, 3, all gone. Four people come to my study. 5, 6, 7, all gone. Then take 8 into my study. This is what known as systematic sampling. Correct? So do we have any doubts now with respect to the sampling part? Anyone? Clear? Everything is clear, no? Okay. So let's have one quiz. So question number 1, question number 2, question number 3. So first question is what? Every 10-person boarding a plane was given a questionnaire. This is what? Which type of technique? Okay, sir, what is the use of systemic sampling? This is to remove the bias. Systematic. No. Every 10th person boarding a plane was given a questionnaire. Okay, let me see the answer. Systematic, systematic, systematic. Completely fine. Yes. How come systematic now? How come systematic? Yes. And of the population. Correct. Anushka, correct. Let's take other example. Question number 2. All the names of the parents were placed in a basket. Then 20 were selected to join the activity. This is what? Simple random. Correct, Carol. Correct. Done. Good, Harshita. Good. Correct, Jyoti. Done. Done. Correct. Let's take one more example. The first 20 people who passed by were chosen to review the taste of the chocolate bar. This is what? Correct, Anushka. Convenience sampling. Correct. Correct. Good, everyone. Good, good. Good. Yes. No more doubts, no? I think this part has been like completely fine to go. So do we have any doubts, any questions? No? Okay. Now the main thing, that is sample size calculation part now. Now, sample size calculation is a process of determining the number of observation or applicates required in a study to achieve a specific level of accuracy and power in the result. Now, let's discuss four important parameters now. The first part, what we are learning is the effect size. Now, if you are dealing with the sample size, you need to learn all these four parameters. Correct? The first thing what we are having is the effect size. So remember a simple thing. Sample size, sample size is directly proportional to the effect size. That means if you are having less amount of sample size or effect size, you are getting more amount of sample size. Simple thing. If your effect size is more, you will get less amount of sample size. Remember a simple formula. Sample size is directly inversely proportional to what? Effect size. Done. Okay. Now we do have some ranges for the effect size. That is what? 0.10, 0.30 and 0.50. 0.10 is what? A small. 0.3 is what? Medium. The other one is what? A large. Done. So if you are having suppose effect size of 0.10, so automatically you're getting a lot of sample size. Why? Because lesser the effect size, lesser the relation between the objectives what you're trying to find out. Correct? That is why we need more number of sample size to identify the effect what you are actually looking for. Correct? So if you are getting a less effect size by the calculation, that means the effect what you are looking for is very much established, like not even try to do for that study. So to find the effect after the main analysis part, we use a large number of sample size, so to identify some major outcomes what we can get. Correct? Now the next thing what we are having is the significance level. We represent the same by the alpha. Correct? This is what the probability of rejecting the null hypothesis when it is actually true. As per this definition, this is what a type 1 error. This is what a type 1 error. Correct? So what is the definition? Nothing but the probability of rejecting the null hypothesis when it is actually true. Correct? That is what known as type 1 error. Now, in the calculation part, we use alpha to be 0.05. Correct? This means what? 5% risk. It indicates that I am taking 5% risk to tell whether this effect will be there or not in that way. Correct? Suppose I am taking alpha of suppose 0.01, change to the percentage part, that is 1%. So it is what? 1% risk of saying that effect exists when it is not existing. Remember this simple thing. Suppose we are taking this 5%, this indicate what? 5% risk of saying that effect exists when it is not there. Correct? So you might have seen some images in this type 1 error, male is pregnant. In type 2 error, female is there, but result came negative. Correct? This is what we are dealing with. So for the statistical part, we always give alpha, that is 0.05. That means what? A 5% risk. That's it. The next thing what we are having is the power. Power is what? A beta. And for the statistical part, formula goes around 1 minus beta. Correct? This is nothing but the type 2 error. Correct? So significance level, that is what alpha, it will handle the type 1 error. 1 minus beta will handle the type 2 error. Correct? Now, this is what? The question comes, okay. So can you please explain the significant level by example? Okay, I will try to show my G Power software to you once. Don't worry, because this will become in the calculation part. This you might not catch up, but try to maintain the alpha of 0.05 and power of 80%. Your effect size will determine the sample size. So I will show you some formulas also. Don't worry, Anushka, for this part. But significance level, you keep around 0.05. Beta, you keep around 80%. That's it. That is the standard what we are following. Okay. So the beta power, the power that is beta, in the calculation part, we write 1 minus beta. That is what a type 2 error. So this is what, suppose if study fails to show effect, but it is there. Again, take the example of the pregnant lady. Suppose one lady is there and she is pregnant. Okay, we can appreciate that, yes, baby bump is there. So what we are appreciating, yes, that lady is pregnant, but blood test came negative. Correct? That is what a type 2 error. Now, statistically, what we are maintaining, we maintain around 80% of power. That is what, let me calculate, it is 0.20. Suppose if your beta is 0.20, so power is what? 1 minus beta. So 1 minus 0.20, it is coming how much? 0.80, or we can say 80%. Correct? Simple mathematics. Okay, not big thing we are doing here. Simple mathematics we are discussing. That is what known as power. Correct? Some people try to go with 90% power. It is also fine to go. Some people prefer 95% power. That is also fine to go. It will minimize the type 2 error because we don't want type 2 error, because type 2 error will mask the effect when it is there. Correct. So this is what we generally follow for the pharma industry, 90-95%, because we don't want to waste the money on the wrong results. We need a proper result. That is why we are maintaining this part. But for UG, PG level, 80% is fine to go. For higher levels like PhD, DM, we try to take around 90%. Correct? The power part. The next thing what we are having is the type of study, whether you are doing a cross-sectional study in which you are taking case and control, or you are having a single cohort of individual, or you are doing a longitudinal study with multiple follow-ups. Suppose in one study you have two follow-up, in other study you have three follow-up, in one you have five follow-up. So for each study you will get different kind of sample size. Correct? Suppose you are having number of groups. Suppose I'm taking case and I'm taking control. So allocation should be what? 1 is to 1 ratio. Correct. If you are following 1 is to 2 or following 1 is to 3, so again number of sample will change for each category. That is why we take the proper history from you, like what you need to do in the study and what you will going to perform. Case control. If yes, then do we have any more than one group? How many patients you are taking in each group? 1 is to 2, 2 is to 1. Or do you have any follow-up? Or suppose, let's take one more part, just for the example part. Suppose Anushka tells, in this study, we are having one individual. I will take two type of patients in case and control. That's it. So in this part, we need to find the sample size with respect to the independent T test because she is taking some blood parameters to check. Now suppose Dr. Vikram is telling I will take only few patients in a single group of patients, or I will call the same individuals after 2 weeks. Okay. So what Dr. Vikram is doing, he called a patient again after 2 weeks, same patient. So in that part, we are performing again a T test, but the pair T test. So again, sample size will be different for this individual. So that is why we need to focus completely on this part, which data, what type of data, numerical, categorical, what you are following. So we can give you the exact sample size. Correct? Now, if you want to try to find something, you can go and search some studies in which you will try to find some mean values. Now, suppose you are doing one study. So, of course, I will ask some parent part article from your side. Like, do you have any sample article on the same topic? Why? To find the mean effect or to find the effect size. Suppose Anushka is performing a study in which she is creating two groups, group number one and group number two, and she will take data in the continuous format. Suppose RBC or LFT, RFT she is taking. So what I will do, I will ask her to send one article to me, like what she is following, and I will calculate the mean effect. So, so if you want to find the mean of two mean study, That is the Cohen's d. That is Cohen's d. So what is the formula? Mean 1 minus mean 2 upon the standard deviation, that is pooled. A simple formula. Okay, and how to find the standard deviation pooled? Again, we have a single formula. That is what? Under root of n1 minus 1 sd1 square plus n2 minus 1 sd2 square upon n1 plus n2 minus 2. Correct? Here, sd is what? Standard deviation. N1 is what? Sample size in group 1. N2 is what? Sample size in group 2. From the article what Anushka has sent. And from that part, I will get the ST pool. And the same I will put in my formula. That is what? M1 minus M2 upon the ST pool. And I will get what out of it? A effect size. Correct? So you people might be using some odd ratio also. So from the odd ratio, we can also find the effect size. That is what? AD upon CD, sorry, BC. That simple table, if you can recall, like this table, what we used to do, correct? AD and BC. So AD upon BC. So you perform this part, you will find one effect size out of it. You people might be running behind the ANOVA also, correct? You might be having a same individual multiple times follow up, correct? So what we will do, SS effect upon the SS total. Correct. You people at the UG level, people are doing a lot of chi-square test. That means we need to follow a separate rule. That is what V is equal to under root. That is alpha square upon n k minus 1. So k is what? A lowest number in the row and column. So this is totally my part, the calculation part. But for as such of now, you should be focusing only on the effect size, how to find it, what's the role, significance level, power, and the type of study. So remember one simple thing, effect size will be changed as per the effect size, whatever we are getting. Significance level, try to maintain of 0.05. Correct. What about the power? Maintain for 80%. Simple. This is what I want from you to remember simple things. Type of study, to leave it to us. Effect size, this is our part. But for the significance level, try to maintain what? 0.05. For the power, try to maintain what? 80%. That's it. So this was all about the sample size calculation. So do you have any doubts or any questions? Okay, so can you please explain? I think that part has been done. Okay, so do we have any doubts, any question now? No? Others? Type of study, that is only that what? Cross-sectional study or case control study, longitudinal study. Done, Aditi? Done, everyone? Do you have any doubts or any questions? Like, I'm happy to help. No? That I will teach you separately. It's not a small topic. Yes. Correct, Gautam. Yes, Vaishnavi, we will share. Don't worry. Okay, so do we have any questions now? Apart from the recordings and all. Yes, doing. Okay. Yes.
Sir,
Come on.
Is it possible that you could explain us finding a sample size by example of some of article or some reference? Maybe it
Uh,
could give us a better understanding of calculation of sample size.
okay, so let me share my screen. I will show you my software because calculation part will take up pretty much more time. So I
Okay,
will show you
so
one software
first,
that is a G Power. So
okay,
G Power we usually use. I usually use, people use EZR, people use multiple things. But
okay. So for mostly sample size calculation, it is done through any of the portal and not manual. Is that so?
yes, we use a software, but for the effect size, we need to do a manual calculation. But even though if you go, you can search online calculator also for the effect size calculation.
Okay.
But I will suggest don't do from your own side because a single mistake can cost the entire paper. So please you do on your own, but please do consult a statistician for the sample size calculation. Do not run on your own because even people from the multiple places they are doing mistakes and papers are getting retracted just because of the sample size calculation. So please consult a statistician if you need to find an exact sample size. Even though we have a G-Power software that is completely free to use, but you should know the basics of statistics, which test will come, what things will come, what data you are collecting, type of data you are collecting, and on that basis, we select the multiple options in the G-Power. Okay, questions are there. Sir, p-value is applicable for almost all. Yes, correct. See, p-value will come for entire things. Even though suppose you are working for some OBGYN or some gastro, some hepato, some social science, some like psychology, psychiatry, everywhere we can report a p-value. But don't report for the descriptive data. I have seen many papers, many people, the PPT during their that part, they are reporting p-value for the descriptive data as well. So that is not correct. So descriptive is like demographic, what we are collecting, 40 male, 50 females in that way. So you can't report p-value for it. Okay. So don't report p-value for the demographic variables. Correct. Any more questions? Anyone? Any questions? Any doubts? No, then I think we can wind up now. Okay. Single population proportion formula manually. Hiba, you can contact me. Like I will help you. Don't worry. That is what. See, your question is like how to calculate the sample size through the population proportion formula manually. It is not eligible, first of all. So I need multiple data from your end, like what type of patients you are collecting. So theoretically, I have understood. Okay. Now, okay, let's take one example now. So suppose Hiba is asking how to identify a cohort, something she was asking. So I don't need a single information. I will get take a multiple sort of information from your part. Correct? So what type of paper you want to perform? Data collection is like what? It's continuous or categorical. Do you have any follow-up? See, because entire things will change the entire statistical analysis part. I am taking data that is in the categorical format. So I need to apply chi-square. I am taking data in the continuous format, then t-test. Do you have follow-ups? Yes or no? Yes, then ANOVA. Okay. Do you have two groups or three groups? Okay, t-test. Which one? Independent t-test. You have single group of patients. Okay. Then what? Paired sample t-test. So multiple things will come up. Not only that simple formula I will give up and something will come out of it. No, this we can't do. Okay, so do we have any more doubts, any questions? Anyone? Any doubts? Any questions? No? Atif, then you can leave the class. It's not my issue. It's completely your issue. Okay, then I think we can wind up. If you need any help with respect to the sample size analysis part, then you can please contact me. I will surely help you. So can you practical example? Okay, I will try to plan one class for sample size calculation also for you all. Don't worry. Okay, I will teach you the proper this way. Okay, then I think we can wind up now. Okay, thank you so much, everyone.